All right, guys, so we're starting chapter 5. Yeah, there's a chance that the battery in it has died out. Yeah, because the TI-30XSs do have batteries in them to help them run, but they mainly use the solar panel to recharge and keep it going longer. Yep. And when they get filled in with pencil, it ends up killing the battery life. But we do have some others that we can replace it with. Now, what we're starting today is chapter 5. We're talking about radicals and rational exponents. Now, the first question is, which is greater? Square root 64 is indeed 8, and the cubed root of 64 is 4. So when we increase the index, or take a bigger root, so taking the 4th root, 5th root, 6th root, what we get, the number we get, is getting smaller. Because when we talk about the square root, we're trying to say what number times itself is 64. Cubed root, what times itself? 3 times is 64. So we're getting smaller numbers each time. Now, this here, you've gone over in Algebra 1. It's been a little while. The nth root of a is equal to a to the 1 over n. Now, a version of this that's a little more interesting is the nth root of a to the x is equal to a. Well, it still holds true that the root is going to go in the bottom of the fraction. Try that again. And the exponent actually goes on top. So the nth root of a to the x is the same as a to the x over n. And the reason that this is actually kind of nice is this actually shows us something that we've just kind of taken for granted or just assumed for quite a while. So if we said the 4th root of a to the 4th, normally we would just say this is what? 4th root of a to the 4th would be just a or 1, right? Because the 4th root and 4 simplify out, yes? And at this point here, we normally just cross the 2 out and moved on. Now, if we rewrite it as a rational exponent, the root goes on bottom, and the exponent goes on top. But what is 4 over 4? Which is just a. This is why they cancel. Because when the root and the exponent are the same, we get this 4 over 4, this 2 over 2, the same number divided by itself, which reduces to 1. So they simplify out. And this is why it works. And we'll get more into this later in manipulating these here. Now, if we look at these first few here, the square root of 9 and 9 to the 1/2. Well, we know what the square root of 9 is. Square root of 9 is 3. Now, 9 to the 1/2, we can do this in the calculator. 9 to the 1/2 is 3. So these here are the same. The square root of 9 and 9 to the 1/2 are the exact same. What would I get if we did 9 to the 0.5? Same thing. Because 1/2, 0.5, they are the exact same thing. So we can do it in either version of this. We can do it in any form. And a lot of times, especially when I'm trying to do quick calculations or we're trying to do, especially radicals, a little bit easier, and I know they work out nicely, in the graphing calculator, I will sometimes do fractional or decimal because they're a little bit easier to type in. Because if we're looking at this here, so if we said 9 to the 1/2, we get 3. We could say 9 to the 1 divided by 3. 1 divided by 3. 1 divided by 2. We would get the exact same thing. Thank you. So any of these work, or we could say 9 to the 0.5. and get 3.
So basically, it doesn't matter which way we have it.
Yes. I'm going to skip B. If we look at C, the cubed root of 8. Now, the cubed root in the graphing calculator is a little bit harder to get to, per se, because it's not listed immediately here. We have to hit math and go down to number 4. 8. And the cubed root of 8 is 2. Now, we could say 8 to the 1 alpha y equals enter 3. We would get 2. Or we could say 8 to the 1 divided by 3 and get 2. Could we say 8 to the 0.3? Because what is 1/3 as a decimal? So this is 3/10. So that didn't get us the same. Well, that's getting us closer, isn't it? Because what is 1 divided by 3? It's 0.3 repeated indefinitely. So there's no real good way to write that as a decimal. Because we can start, if we put enough 3's, it'll get close enough to it that it'll approximate it. But really with 0.3 or kind of 1/3 or 2/3, it's going to be better to just leave it as a fraction than a decimal. 1/2 worked out nicely. 3/4, stuff that has a terminating decimal, we could put it as a decimal or as a fraction. Either one works just fine. So both of these work out to be 2. So we can have it in either form. Questions on any of this here? Now we can evaluate radicals and exponents at the same time. So we could take parentheses, second square root of 5, close parentheses, to the 3rd. Yep. So on the graphing calculator, we can do parentheses, second square root 5, close parentheses, to the 3rd. And we get the exact same thing. Now, we can manipulate this a little bit, because I could rewrite this as a rational exponent. Now, the exponent with the 5 is 1, so the number on top of the fraction would be 1. The number on bottom would be 2, because the number inside the radical, if it's not written, is understood to be 2. Now, powers of powers multiply, so 1/2 times 3 is 3/2. And if we type this into the calculator, 5 to the 3 divided by 2, 3/2, we get the same thing. So 5 to the 3/2 and the square root of 5 cubed are the exact same thing. Now we can look at the next one, the 4th root of 4 squared. So we can do 4 second nth root of 4, close parentheses, squared, which will tell us that it is 2. Now let's try rewriting this as a fractional exponent. Well, the number or exponent with the 4 is still 1. The bottom of it would be 4, because the 4th root is the same as 1/4. Now powers of powers multiply, so 1/4 times 2 is 2/4, which is 1/2. I mean, it's good to know. And the 4 to the 1/2, well, 1/2 is the same as what? And in radical form, it would be square root of 4, and the square root of 4 is 2. or we could say 4 to the 0.5, which is 2.
I put it into the calculator so I can always submit how many papers it's for. That's the one.
So
I had to get your 4 little. My 4 is little. Not math. Oh, math?
because I think that's how you have it. Now, parentheses 4, second.
Oh, got it.
Yep. Any other questions on these here? Now we can also do it with fractional exponents from the beginning. 8 to the 2/3. So in the calculator we can do 8 to the 2/3. 8 to the 2/3 is 4. And we can also do 6 to the 5/6. Not 5/6, 5/2. Yep. 88.18. And in either case, this works. Now, I'm going to write this up here so we have something to reference these two. But what is 8 to the first? 8 to the first power. Yeah, anything to the first power is itself, yes? So, when we took 8 to the 2/3, is it reasonable to expect that the number would get smaller? Because our exponent is what? Compared to 1, it is smaller. It's less than 1. So the number that we get out of it should be smaller than the number we start with.
So basically what you're saying, the bigger the number is.
Not so much, we can't say proportionally, but if the exponent's bigger than 1, the number should be bigger. Because 5/2, 2.5 is bigger than 1, yes?
Yeah.
So what we get from 6 to the 5/2 should be bigger than 6.
Oh, I just confused myself.
Questions on these here? So we'll look at these here without a calculator, and then we can, especially doing them with a calculator is not that bad because we just plug it in. Now, if we wanted to look at this without a calculator, one of the biggest things is rewriting this, splitting this back up. So we'll have the 4. I'm going to put the numerator outside and our fraction on the inside. As the numerator is 3, so we move it out front, outside, and we have the fraction left over. Because we can agree taking the 3 out, that would leave us with 1/2. Because 3 times 1/2 would get us 3/2, yes? Now 1/2 is really saying what? As a radical, our square root, yes? So if we wrote it as a radical, we still have the 4 inside. The exponent attached to it's 1, and the root would be 2. Now what is the square root of 4? And 2 cubed is? Is 8. Questions on how we did this here? I mean, there are different ways we can do this. So I'm going to look at one other way. Is 4, can we rewrite 4 as a number to a power? Because 4, I can write to the side, is what? 2 times 2, or we could say this is 2 squared, yes? So we can rewrite 4 as 2 squared. Now powers of powers multiply. So this is the same as saying 2 times 3 is 6 over 2. Well, 6 divided by 2 is, which is still just 8. It's just other ways that we can manipulate this. 32 to the 4/5. Well, 32 is what? 2 times 16 is 2 times 8. 8 is 2 and 4 is. So how many 2's do we have? 1, 2, 3, 4. So we can say 32 is the same as 2 to the. So this here is 2 to the 5th, 2 to the 4/5. Powers of powers multiply. So what is 4/5 times 5? Well, 5 times 4 is 20. 20 divided by 5 is. Now we just need to figure out what 2 to the 4th is. 2 to the 4th is. And that's it. 32 to the slapping it or putting it in the calculator works nicely as long as the number we get is a nice number. And all the ones that we'll have so far are going to be nice. So these here, we can plug them in, and the calculator does give us nice numbers. Questions on any of this here? The other thing that we're looking at today is the real nth roots of a. Now, there's two setups that we have. We have that the root that we take is an even integer, or the root that we take is an odd integer. So when we talk about odd integers, we're talking about 3, 5, 7, 9, going on. Now, when we talk about the odd integers, we have one of three cases. So if we take the odd root of a negative number, we have one real root. It's just going to be whatever that root is, the odd root of it. If we take the odd root of 0, when a is 0, well, we have one real root, and it is 0. And the last one, if we take the odd root of a positive number, we have one real root. So really, if we take the odd root of any number, we have one real root, and whatever that is. Now, the other case is the even integers, 2, 4, 6, 8, going on. And we take the even root of a negative number, we have no real nth roots, because this is where our I came in, these imaginary numbers. So I can't take the even root of a negative number and get a real root or a real solution out. Now, if we take the even root of 0, we have one real root, and it is 0. In both cases, I mean, no matter how many roots we take of 0, we still get 0. Now, the one that's kind of important is if we take the even root of a positive number, we get two real nth roots. We have to add the plus or minus. So, if we look at these here, the first one, so this is all dealing with the nth root of a. So for the first one here, we're taking the cubed root of negative 216. Since we're taking the third root, the odd root, well, no matter what goes inside, we're only going to have one real root. And we can just do this here. So we can do 3, negative 216, and it's negative 6. And that's the only real root. That's the only root that we have for this here. And we could do it in a calculator. We could say negative 6, parentheses negative 6, to the third, and we get negative 216. We can't say that it's true for positive 6, because positive 6 cubed is positive 216. So negative 6 is our only solution for this here. Now, if we look at the next one, the root we're taking is so the fourth root of 81. Careful. There are going to be 2, and it is 3. But what else do we need? We need the because positive 3 and negative 3 would work for this here. So if we said negative 3 to the fourth, we get positive 81. And 3 to the fourth is 81. Because for the first one, so we're saying negative 6 times negative 6 times negative 6. And we end up getting negative 216 here. Now, if we did it with positive 6, we would still get 216, but it would be positive, not negative. With the even number, the negatives end up canceling each other out. That's also why we can take the odd root of a negative and not an even. Let's look at these last two. For the next one, we're going to take the fourth root of 16, which is going to be 2 is half of it. It would be plus or minus 2. Because since it's an even root of a positive number, we need the positive or negative. Last one we're looking at is the square root of negative 49 is because we would have plus or minus, so it would be 7. Because we have negative. But again, we're asking for the real root, so this here has no real nth roots. And if we go, I'm going to go back 2 slides. Because if we take an even root of a negative number, there are no real nth roots. Because we can't take the even root of a negative number. Questions on this here? And that is it.